So, Prashanta, did you watch the recording?
Yes, sir. I watched it today.
So, you have any doubt in that?
No, sir.
Okay, so guys, tell me, what is sine of A plus B? What was the answer?
Sine A cos B plus cos A sine B.
Okay, very good. Now, assuming that you know this formula, can you derive the formula of sine of A minus B? And the answer is very simple. You can always write this as A plus minus B, right? And then you can apply the plus formula. So the only thing is the B we can replace by minus B. And if you replace B by minus B, what will happen? So it will change something, it will not change something. So this will become sine of A cos of minus B plus cos of A and sine of minus B. And the last lecture we derived something. What is cos of minus theta? So minus angle represents that you must turn clockwise. So minus B will be in which quadrant, guys? If you remember the quadrant. So sine of minus theta represents which quadrant?
Third and fourth. Minus theta. Sine minus theta.
Minus represents which quadrant? Fourth or
Yes,
third
the
or
fourth.
one? Only fourth quadrant, right? So because it's the fourth quadrant, so sine in the fourth quadrant will be, the cos in the fourth quadrant is positive or negative? Cos in the fourth
Positive.
quadrant is positive. So the cos of minus b remain cos b. So the term with cos of minus b will not be affected, but sine of minus b becomes minus of sine b. Correct? If you remember. So sine in the fourth quadrant is a negative number. So this we can write as minus sine. Is this clear? Yes or no? And therefore,
Yes, sir.
sine of A minus B turns out to be how much? Sine A cos B minus cos A sine. So the minus will come into the picture as simple enough to remember, but it's also easy to derive. So similarly, can you tell me the answer for cos of A minus B?
Cos A cos B plus sine A sine B.
Very good. So cos A cos B plus sine A. Because the plus is having minus sign, so minus will have the plus, right? Because sine of minus b becomes minus, which will make it plus. So I hope this formula you can easily derive and easily remember as well. A plus b minus b. And the last, what about the tan of a minus b? So tan of
Tan
a
A
minus b.
minus tan B upon 1 plus tan A tan B.
Very good. 1 plus tan. So we can now put these formulas into some use. I mean, we can create many formula, of course, but we'll do one by one. So first of all, assuming you know the certain values, let's say the typical values that we should remember are 0, 30, 37, 53, oh, 14 seconds, 45, then 60, 53, 60, and of course you can keep on adding like this. So 75, oh, no, 75. Okay, that's it. I think 90. So you know this basic one. So what I'll assume that these are the typical values that we are supposed to remember for any trigonometric ratio, whether it is sine, cos, tan, and whatever. Now the question is, by taking any two values out of this entire set of values, we can create a lot of other angles which is typically not seen before. So for example, if I add these two, what I can create? 75. Okay, which is typically we can write as 30 plus 45, isn't it? And similarly, if you subtract these two, which is very interesting, if you subtract 53 minus 37, what will you get? Any guess? 53 minus 37 is how much?
16.
No, that is something very interesting. That 16-degree, which we cannot think of finding the value, is possible because of this relation, the plus minus relation. So we can add this is 53 minus 37. And now to create any random value, let's say I say 83-degree. So 83 we can rewrite as 53 plus 30. Again, this is something weird which we don't know how to find, but this is possible to find, right? And knowing the 83-degree, we can also find the 7-degree, which is like 90 minus 83. So there are many ways in which a question can be manipulated to get something which we never dreamed of finding with usual values. So the plus minus is very useful to know certain values which are not very direct value, but that can be achieved through manipulation. Okay, so that's why the manipulation part, because we know the manipulation, we can use these formulas to our advantage. So let's see some values which one should know. So let's say I'm looking for values sine 15-degree. How to find sine 50? Anyone? Sine 15.
Just 45 minus 30.
Very good. So you can write this as sine of 45 minus 30, and then we can use which formula? Sine of a minus b, right? So the answer will be how much? Sine of a cos of b minus cos of a sine of b. And how much this turns out to be? Sine of 45 is how much, guys? Tell me.
1 by root 2.
And cos of 30?
Root 3 by 2.
Very good. 1 by root 2. And sine 30 is 1 by 2. So you can see pretty much the LCM is known to you. I mean, LCM is common. So it will be 2 root 2. And the numerator becomes root 3 minus 1. So this is the answer for sine 15-degree. And this is how much? Roughly, this value is how much? Can you calculate the using calci? Let me find it out. So root 3 minus 1. Root 3 minus 1 divided by 2. Divided by 3.
So it's 0.2588.
Yeah, 0.26. Let's keep it 0.26 roughly. So this is roughly 0.26. Okay, not degree. This is just a value. So roughly it is 0.26, which is a good number to remember. Sine 50. Okay, anyway. So similarly, can you find the cos 50? Cos 50.
So root 3 plus 1 by 2 root 2.
Correct. So it becomes just plus, right? And why not? Let's find the tan 15. So tan 15 will be how much?
Root 3 minus 1 upon root 3 plus 1.
Very good. That's a really interesting answer. So root 3 minus 1 upon root 3 plus 1. So you can find any value. So let's find some really weird values. So if someone is asking you, can you find the value? We have done this part, I think. The double angle formula. So, okay. What is the value of sine 106? And which formula will help us here? I hope you remember some of the derivation that we did using those formulas. So there is something called the double angle formula, right?
Yes, sir.
So, what
So
is
we
best?
can take 106 as 2 into 53.
Very good. So we can write as 2 theta, which is 2 into 53. So sine of 2a is what? 2 sine a cos a, right? If you remember, double angle formula. This
Yes,
is a
sir.
very common formula. So this is 2. And sine 53, we know it's a 4 by 5. Cos is 3 by 5. So it turns out to be how much? 24 by 25, right? Yeah. So sine of 106 is 24 by 25. I hope this is clear.
So sine 53 is 3 by 5.
Sine 53 is 4 by 5. Sine 37 is 3 by 5.
Okay.
Always draw the triangle 3, 4, 5 triangle if you remember. 3, 4 is bigger. Let's make it extra bigger. And this is 5. So 3, 4. So this angle must be 37. This is. So sine 53 is how much? Tell me.
4 by 5.
So I think I'm correct. What I've written is right.
Yes.
All right. So let's derive something more. From the double angle, we have derived something. So sine 2a we have derived 2 sine a cos a, and just okay. So what is cos 2a?
Cos square a minus sine square a.
Cos square a minus sine square a. And this we can rewrite in multiple ways. We can write as 2 cos square a minus 1 by converting sine square into 1 minus cos square. Or we can write this as 1 minus
1
2 sine
minus 2
square a.
sine square a.
Very good. So sine square and cos square can be written in a single format of cos 2a. So cos square a we write as 1 plus cos of 2a upon 2, and sine square a we can write as 1 minus cos 2a upon 2. So this is something, a conversion formula. And if you divide these two formula, you can get tan square a very easily. So tan square a we can write as sine square a upon cos square a, which is nothing but 1 minus cos 2a upon 1 plus cos 2a. And therefore, what you can realize that everything, the square of trigonometric ratio can be expressed uniformly in terms of cos 2a formula. And that is why this formula is very, very powerful. That if I want to convert some formula into a uniform formula of single variable, let's say cos 2a is a single variable. So you can see every answer is in terms of single variable, isn't it? And that is something which we have to use somewhere, maybe while doing integration, while doing the trigonometric equation, their solution. So these ideas will help you. Okay. So you can also write tan a equals to under root of, because it's a square. It will be plus and minus, but I am just taking the plus value, the first quadrant value. In maths, you have to take both the plus minus both. Okay. So you can also get the answer from here. What is tan 15 degree? Now we know the double value. We know tan 30 value, or we know the answer for 30. So we can attach 1 minus cos 30 upon 1 plus cos 30. Okay. And this is how much? 1 minus cos 30 is 1 minus root 3 by 2. This becomes 2 plus root 3. Sorry, 2 minus root 3 upon 2 plus root 3 under root. Now, this is something really interesting. And what is interesting? The interesting part is, okay, I'll tell you something. What is root 3 minus 1 whole square? You know, a square plus b square minus 2ab. Correct? So if you look carefully, this is nothing but the understood. So this root 3 minus 1 whole square is really interesting term. And similarly, the 2 plus root 3 will come when you have to root 3 plus 1 whole square. These are something well-known expansion, and you're just supposed to be aware of this, that okay, I can convert 2 minus root 3 as root 3 minus 1 whole square by 2, something which is not commonly seen. Okay, I'll put on the next page. Anyway, so my answer is here tan 15 we can write as multiple ways, 2 minus root 3 upon 2 plus root 3. I hope you are aware of something called normalization, okay, or rationalization, what we call. So if you rationalize, what you can do? Multiply the opposite of denominator, right? So denominator is this, multiply. If you rationalize, what we get here? So 2 minus root 3 is the answer, right? You can see, check. Isn't it? Can we write like this? Hello, hello, hello. Everyone knows rationalization. How to rationalize? To rationalize the irrational number. So in the process of rationalization, the denominator must be a rational number. Now root 3 is irrational, so what we do? We multiply with 2 minus the, we change the sign, and we multiply in the numerator and the denominator to get the answer. And this will give you this answer. Now it will look very much different from the answer which you obtained, but both are same. How? If you rationalize this, you will also get the same answer. So how to rationalize this? So this will give you 2 times 2 minus root 3. So root 3 minus 1 by root 3 plus 1 is 2 minus root 3. That's proof. I hope this is okay, guys. No response I'm getting. Are you guys getting this? Yes or no?
Yes, sir.
And do you have a difficulty with rationalization? So there is a simple theory of rationalization that we study in class, maybe 7th, 8th. So to rationalize, we make the denominator a rational number. That's called rationalization. Meaning of rational, to make it rational. So the square root of a number is irrational if it is not able to, if it is not a perfect square. So if a number is not a perfect square, then its square root will be irrational number. Okay. And you are supposed to rationalize. So to get rid of this, we use a simple trick: a minus b into a plus b is a square minus b square. And the moment you square of any number is rational, right? Isn't it? The root will vanish. And the difference of two rational numbers will be rational. Hello, 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 hello. Are you getting it? Yes or no?
Yes, sir.
Okay, so we have so many formula to derive, to write. Let's practice something more. So find the value of cos 97. What is the value of cos 97? Tell me, guys.
The 60 plus 37.
Very good. So you can write as cos of 60 plus 37. Very good. Then you can get the answer for sure. So the next step is finding the a plus b formula, which you can write and get the answer. Anyway, so I'm leaving this part. I hope you can do it. Now, who will tell me the value of so I want the triple angle formula. I think. What is the value of sine 3a?
3 sine A minus 4 sine cube A.
Very good. And cos 3a?
4 cos cube A minus 3 cos A.
Excellent. So you remember all this, right? So you can derive it. I hope so. So please, everyone derive this formula. So your job is simple. First, you write 3a as sine of a plus 2a. Then you use the double angle formula, like a compound angle formula, sine of a plus b. Once you have broken, then further replace sine 2a or cos 2a by their respective formula, and then convert eventually into the desired formula. So that's a practice which you must go through. So tell me what you're getting quickly. Done, guys? I want the answer through expansion, because what really matters is the ability to manipulate the equations. And in Trigo, the more you do the dirty job of manipulating, the more you will feel confident in manipulating the equation. So please do this. Yes, Siddhant, tell me, are you getting the answer?
Yes, sir. I'm getting the after simplifying. I'm getting the same answer. The
Very good.
first sine 3 sine A minus 4 sine Q.
Yeah. You're able to arrive at the answer, right? Through the basic.
Yes, sir.
Yeah, that's great. Anybody else? Prasansha, you got the answer?
No, sir, I'm getting something else.
Oh my God. So you only remember the answer.
Yeah.
That's dangerous. Okay, anyway. Okay. So let's say if you have a car and you know all the theory that the accelerator takes it forward, steering turns, is it sufficient to drive on a road? It's dangerous. Same thing is with maths. If you know the formula but not the derivation, it is exactly like you know the functioning of various part, but still you cannot drive it, or you can say derive it. It's the same thing. So always make sure that everything you can derive, even if you don't know. Sine A cos B plus cos A sine B. So the single angle is okay. Whenever we have double angle, we have to further break it down. That's the whole idea, right? And cos 2A, because I want the answer in terms of sine, can I write as 1 minus 2 sine square A? We have learned this part. And cos A is fine. I cannot do much here. And sine 2A, we can further write as 2 sine A into cos A. Correct? So now we have sine A minus 2 sine cube A. And then I have 2 sine A into cos square A. I cannot do with cos, but I can do with cos square, right? So 2 sine cube A plus 2 sine A. And cos square, we can further write in terms of sine square is 1 minus So now you can see sine A minus 2 sine cube A plus 2 sine A minus 2 sine cube A. Oh, so we are done. Not very difficult, just manipulation. So sine of 3 it turns out to be how much? 3 sine A minus. So you have to do this manipulation. See, what is really important is not the formula. It is the ability to transform these ratios into a desirable relation. And that is the thing about trigonometry. In trigo, if you want to learn something, make sure that you are able to do the manipulation. Okay. Not very difficult. I hope so. Can you similarly derive the cos 3a formula, please, everyone? I see. I really do not want you to know the formula. You know the method, the process, which can help you in case after 1 year, if you don't know anything, you can still derive it. And everything you're learning will have application in physics. So we have a chapter called wave and sound chapter and SHM. These three chapters are entirely depending on the trigo. So it is like everything you will do is based on trigo only. And if you do not know how to manipulate, you will have the same difficulty as you're feeling right now. So if we are doing something, it means there is a consequence in physics. So imagine an entire 3 chapter based on pure trigo only, just trigo manipulation. So are you guys getting the answer for cos 3a in a similar fashion? Keep on doing till you get the answer. You write one step, then you will find okay, what is the next step possible? You will see the step, do it further, wait for the right term. The moment you are getting the equation which can be transformed, transform it.
Yes, I got it.
Very good. So this is 4 cos cube a minus 3 cos a, right?
Yes, sir.
And this will give you a kind of another formula or something. So what is the value of sine cube a? So sine cube a will be 3 sine a minus sine of 3a upon 4. And the cos of cube a will be how much? 3 cos a plus cos 3a upon 4, right? So it is like eliminating the power. So what I have done is I have converted the power 3 to power 1. So these all are single power term. Okay. And let me show you tell you something about the future, that what you are going to actually use these ideas. So the entire, if you look at the present scenario, we are talking about Alexa, Google Assistant, and what once more? One more is there. The
It's a series.
Siri, right? So all these voice assistant, how they work? So these voice assistant work on something called Fourier transform. Now Fourier transform is basically a very advanced concept of trigo. You can imagine it's like a sinusoidal wave. Everything that we speak is a sine function. You can just remember this way. So whatever we speak is called sine function, and what you see a 3a, these are called frequency. So if I call a as a frequency, so sine a is representing one particular frequency. So sine 3a is representing a frequency which is thrice of the first frequency. Okay. So a cube term in a mathematical function is equivalent of presence of two types of frequency. So sine of 3a, sine cube a, is actually obtained when you mix frequency of value omega and 3 omega. Let's say we have two types of frequency. So if you mix a frequency f with 3f, you will get a function like sine cube a. So all these voice assistant, what they do is they capture the human voice. They use some mathematical tools called Fourier transform, and they break down into various sine function, and they check the frequency. Okay. Every human being will have a typical set of frequency that we use to speak. So by looking at the frequency, they identify that, okay, who is speaking. Let's say I am speaking or you are speaking. So we all have a very unique pattern of frequency that we generate using our sound box and the vocal cords. Okay, so we set our vocal cord into oscillation, and that vocal cord creates the air burst, and the air burst will have the similar frequency as that of the vocal cord, and that is how we speak actually. And then what we speak will reach the eardrum. It will set the eardrum into oscillation with a similar frequency, and this frequency will be again regenerated into some electromagnetic pulse, and that pulse will travel through the optic nerve in the brain. It will reach a part of brain where it will decode as sound. So it's a very complex process. Now trigo is actually a way to decode these frequencies actually. So in sense of sinusoidal function, the angle represents kind of frequency. So it is a way to understand the frequency term, and there are many interpretations for sure. But what you need to understand that when we are learning trigo, we are actually going to become expert in the speech technology. Okay. Of course, the method to deal with such complex terminology will not be as simple as this, but what you're learning is the base of all those heavy stuff in future. So if someone is going to graduate in electrical engineering from IIT Bombay, so you have a special paper that's called speech technology. Okay. And most of the electrical engineers, they actually help in creating this voice assistant, that how they sample the voice, they create the frequency layer, and they divide the frequency into some pattern, and then they code into some formula. So we have specialized coding or libraries available in Python, which takes care of all those things. And those who are expert in that, they create the programming for these devices. Okay. So basically in all of these devices, what they are having is a filter called a speech filter, and this filter are programmed as per the Fourier transform. So Fourier is a very great mathematician from the, you can say, European country, somewhere maybe I think Italy or not. He's from France only. James Fourier. Okay, so he was the person who understood that every complex voice or speech is nothing but the combination of multiple sine function. So that was his advent or discovery, you can say. And using those sine function and its combination, he was able to derive every frequency that a human can speak possibly. And that's how the birth of Fourier transform took place. which is in essence the basic trigonometry. So as you move further in the course, you will have some interpretation. Of course, these things cannot be taught at a undergrad level, like what you are learning right now. I'm just trying to give you that, okay, what you're learning is not simple. I mean, it will have far-reaching consequence, but to realize those consequences, you have to wait for a long, long time. Of course, when you graduate, when you go in the BTech, you will come across all those things. Okay. So don't take everything just like mathematics. I'm trying to give you some suggestion like how this will be mapped to the real world. Okay. And then you can realize that, okay, the cube of a sine function is basically a frequency, two types of frequency. It's a combination of two types of frequency, you can see. So what is the frequency here? A and 3. And if you remember sine square A is what? We can write as 1 minus cos 2A by. So the frequency of this function is actually not A, it is 2A. Here we have types of frequency. And the same idea we use in something called communication chapter, and we have something called the band of frequency. So we have lower band, upper side band, lower side band, and then we have bandwidth. So when we have a range of frequency, then we have a bandwidth. So all this telecom operator, whether it's Idea or Airtel, Geo or whatever, so government has given them a bandwidth through which they can transmit their voice signal. Okay. And that is how the communication will take place. So we have multiple technology called TDMA, CDMA. Now it's obsolete. Now they have advanced technology. The 5G technology is quite different. So earlier we had a TDMA, FDMA. TDMA is called the time division multiple access. FDMA is called the frequency division multiple access. And long time back came when Geo launched its first mobile phone. That time there was a technology called CDMA, the code division multiple access. Now, what are all these things? Of course, not part of your syllabus. I'm saying all this because I am electronics engineer. Okay, so I know a lot about communication. These things are inbuilt on those technology. Okay, and to see the technology through the mathematics will take a lot of time. I mean, of course, as of now, you won't be able to see all this thing, the direct correlation. But when you are learning something, just trust my word that it will have a far-reaching consequence. So don't read it. I mean, this as something to cover up. Try to understand the meaning, and I'm trying to give as much possible information to you guys at this stage. Okay, so there's a meaning to it. This the high power. What you're realizing here, every higher order trigonometric ratio. Try to understand what I'm saying. Every high order trigonometric ratio can be broken down into the first order combination of sinusoidals. Once again, high order trigonometric ratio can be thought as, can be converted into first order. What is first order? Power 1. So high order means power 2, 3, 4, 5, 6. So any high order trigonometric ratio, and I'm particularly talking about the sine and cosine, any high order sine or cosine function is nothing but combination of first order trigonometric function. It's combination. So you can see this high order cosine function is a combination of the first order function of A and first order function of 3A. So the 3A and A later on in some context we are going to call as frequency term. Okay, so you will of course learn about all those things as time will come. Don't worry. Okay, so that's really interesting. Conversion of high order into low order is the primary goal in physics. Okay, and that is where what we apply in the chapter of wave and sound chapter. Okay, so you need to know these relations where you always able to convert the high order into the low order. Okay, so don't worry, everything will not come in one day, but a slight idea will help you certainly in future. Coming back to the derivation, now I'm looking for some interesting derivation. So So if we add the summation and difference, sine of a plus b plus sine of a minus b, what we are going to get? So you will tell me all these answers. Sine a plus b minus sine a minus b, cos a plus b plus cos a minus b, and cos, now this is actually going to be negative number because cos of a plus b is a small value than cos of a minus b. So this will give you negative answer. Do you realize this? Cos of big angle is small value, like cos 90 is 0, but cos 0 is 1. So a bigger angle with cos is a smaller in value than a small angle with cos, and therefore this will be a negative answer. But you will get the answer if you do it. But tell me all the 4 answers. So who will tell me the first answer?
I got it.
Sir, 2 sine A cos B.
Very good. I think okay, person says I remembered every formula. I'm very proud of you, but do try to derive it also. Okay.
Yes.
What is the second part? Who will tell?
2 cos A sine B.
No, you will not tell. No, everyone else will. They get the time, a chance to say. So okay, Siddhant, you can tell.
Yes, sir. 2 cos A sine B.
Then next, okay, Shreya will tell me this answer. What is cos A plus B plus cos A minus B? Okay, Tanish, you can tell.
Just a second, sir.
Okay, Rugved, you can tell me the last one.
2 cos A cos B.
The last one. This one.
2 sin A sin B.
Yeah, 2 sin A sin B. Let me see. 2 is 2 sin A sin B. Yeah. just a minute.
Negative.
I think minus cos A cos B minus sin A sin B. And cos A cos B plus 1. It's minus, right? Minus. Yeah. It is going to be negative only because anyway, I told you that the cos of A plus B is a small value. Cos of A minus B is big value. The answer is going to be negative for sure. And what about here? Two cos A cos B, right?
Yes,
Yes,
sir.
sir.
Now I will tell you something again. There is a simple pattern. If you have realized, the sine always gives you the mixture, and cos gives the filtered version. Like cos is like filtering. You filter the cos separate and sine separate. So the moment you see something like this or like this, you know it has come from the cosine relation, because only in cos we have cluster of cos together and sine together. And if you have the mix, the sine and cos coming together, you know it must be coming from the sine function. Okay. So there is something called the something called product formula. Okay. So if I let if I call A plus B as C, and if I call A minus B as D, let. What will happen if you let like this? Then we can add A as, if you add these two, it will give you C plus D by 2. And if you subtract these two, you get B equals to C minus D by 2, right? And now using this 4 formula, I can derive further 4 more formulas. So what I can derive? Sine C plus sine D. What is the answer, guys? 2 sine A cos B. Correct. And sine C minus sine D. The moment you minus, subtract, what will be the against answer? Please guys tell me the answer. Anyone? Sine C minus sine D. What I'll get?
2 cos C plus D by 2 sin C minus D.
Correct. So sine C minus sine D becomes cos, but sine C plus sine D becomes sine. Okay, when you are adding, it begins with sine. 2 sine A cos B like this. Anyway, next formula is cos C minus cos D. Cos C plus cos D first. Yeah.
Two cos C plus D by two cos C minus D by two.
Very good. It is cos and cos, right? And the last, cos C minus cos D.
Minus 2 sine C plus D by 2 sine C minus D by 2.
Correct. Now, in many books, they don't want to put minus sign here. What do? They bring the minus here and they alter the position because sine of minus theta is minus sine theta. Correct. So this we can rewrite as, and that is what you will see in book, 2 sine. They don't put the sign outside, rather they take it inside and they alter the position D minus C by 2. That's why this formula is very difficult to remember. Cos C minus cos D is 2 sine C plus D by 2 into sine D minus C by 2. Okay. Now, when you open a book of SL only, you will get every formula will have one chapter where you have to only do the manipulation. And while doing, if you do right now, I mean, that's very good time to do. You will be able to finish 2 chapters. I mean, in fact, your 50% trigo will be over. In fact, 70%, I think. And then you will be at ease. Your 1 chapter of maths is gone. Then you can focus on other chapter. And the best thing is, anyone good with trigo will have the advantage of understanding complex number with ease. Will have the advantage in calculus. Will have the definite advantage in algebra. So advantage will be everywhere. And trigo is not a chapter. It's like the basis for learning entire maths. Okay, so you should know that how to manipulate and derive. I can keep on teaching this entire chapter. So I'll just teach a bit more and then I'll stop because there is no end to it. Because mostly it is manipulation. Okay. And now you can you will understand why we need this manipulation. So see, the sum is becoming product. The benefit will be when the moment we take the ratio, you know, the manipulation will be much faster if I convert into product because we can cancel the product, isn't it? So that's very interesting part. And yeah, that is how it goes. So you need to know that, okay, do I need to convert sum into product? Is it required? Is it going to be helpful? Then you will recall the sum product formula. Okay, so you can call it sum product relation. And this is the by far the most important relation in trigo because most of the trigonometric relation that we derive, it will use this kind of convergence. And also the trigonometric manipulation is a powerful, you can say, a method to learn all those, you know, rearrangement process. After some time, you will be very much okay with this idea. It's not difficult. Okay, so one more formula I would like to give. What is tan of A plus B plus C? I have missed this part. Tan of A plus B plus C. No, don't worry. You know what to do. You can take this entire term as one single term and then write the A plus B formula. You can call it this as B dash. And you know how to proceed. You can add tan A plus tan B dash For 1 minus tan A, then B dash. Always know how to derive. And then you know how to write B dash further. So I'll just write for you. And then you will further manipulate tan A, tan B plus tan C, 1 minus tan B, tan C, all divided by 1 minus tan A, then tan B plus tan C, 1 minus tan A, tan B, tan C. And then you have to simplify further. Let me do it. So tan A, and then you can put LCM if I take minus tan A minus tan A, tan B, tan C plus tan B plus tan C. Really bad way of writing. But anyway, I know the LCM will cancel out, so I can write as 1 minus tan B tan C minus tan A tan B tan A tan C, which you can write as, you can see this is really interesting. So tan of A plus B plus C from a turns out to tan of A plus tan of B plus tan of C minus tan A tan B tan C all upon 1 minus, you can say AB, so tan A tan B cyclic equal to minus tan B tan C, and that is tan C tan A. Done. Very simple. And in Trigo you will learn something interesting, that if A plus B plus C equals to pi, which is that if these three angles represent the angle of a triangle, then tan pi is how much? 0, correct? And when the tan pi will be, when the tan will be 0, when the numerator is 0, right? And that will give you the very interesting relation that the tan of A plus tan of B in a triangle, the tan of the three angle is always product of the angle. See, these are some beautiful relation that, of course, these things are used only to solve mathematics. You can also get to know if the sum of the angle is given something pi by 2, then what to do. If I say if A plus B plus C is pi by 2, then what will happen? The D numerator becomes 0, right? Isn't it? If I give pi by 2, the answer must be infinite. And it is infinite only when this term is 0. Hello, hello, hello.
Yes, sir.
Anyone realize this part, what I just said? Maybe not. Anyone who realized this part?
Yes.
So if the sum is 90 degree, just I'll mention it here. So if A plus B plus C is 90 degree, if it is given to us for some reason, then tan of A plus B plus C, because tan 90 is undefined, or you can say infinite. And it is undefined only when, so in mathematics, what is undefined? When the denominator is 0.
0.
So this will become 1 equals to tan A tan B plus tan B tan C plus tan C tan A. And again, let me tell you, you are going to forget everything I'm teaching here. I know this, but it really doesn't matter, because what you read once, and even if you forget it, when you see it for the second time, you will have better understanding. So my idea is, okay, when you will revise or you will see in maths, you will have some comfort than rest. That's it. And I really don't expect that you should remember everything I'm teaching. No, I want you to learn some process in the whole gamut of things. Learn the process, what I do to get to derive something. If you're watching my process, you're learning something. If you're watching the end result, you're not learning anything. So don't try to watch the last answer which I derive. Just try to focus on my process. That's my request to all of you. Always focus on the process of a teacher. You will end up becoming a really good student. That's simple. Only focus on the process. That is more than sufficient. Okay, so I can keep on teaching. I mean, there's no end to it. But what I'll say is start doing the learning, and you will be able to solve many chapters, like 5, 6, 7, 8, 9 chapters. So you know Heron's formula? Heron's formula? If you have a triangle, so if you have a triangle, what is the area of the triangle? If this is A, B, and C. So this is called A in length, this is called B, and this is C. And we have something called semi-perimeter, right? Semi-perimeter. And how we represent semi-perimeter? By symbol S. So what is the S value, guys? What is S?
A plus B
Plus
plus
B
C
plus-
by 2.
Very good. Okay, you guys know. It's a half of the perimeter of the triangle. Half of the perimeter of the triangle. A plus B plus C by 2. All right. What is the area of triangle? Which Heron gave?
S into S minus A into S minus B into S minus C.
Very good. And we can derive it using basic theorem. So I'll just show you the derivation quickly, just for fun. Of course, you can do this calculation at home. Do you remember that the area of a triangle we derive in vector chapter? You know how we derive? Half AB sine C or something like this, isn't it? Half AB sine C or half BC sine A or half CA sine B. Do you remember this? That area of a triangle formula in the
Yes, sir.
cross product chapter. And this is what we are going to use to get our answer as well. So we have to use the something simple called cosine formula. What is cos of A? If you remember, cos of A we have derived. So cos of A is B square plus C square minus A square by 2BC. Correct? Can we write like this? Yes or no?
Yes, sir.
Yeah. No, we can write like this. All right. So the cos of A we can also write as in terms of sine. Anyone who remember this?
Sir, cos in terms of sine.
Hmm.
Sine 90 minus A.
So you can add like of course you can add sine A equals to 1 minus cos square A, like this, simple, right?
Yes, sir.
Uh, this is going to be a square root term, so not very much favorable. So we can do something else. What to do is we can also write cos A as 1 minus 2 sine square A by 2. That's easy, right? So this will give no root term. And therefore, I can derive the formula of 2 sine square A by 2. And this turns out to be how much? 1 minus B square plus C square minus A square by 2BC. Okay, so this is 2BC minus B square minus C square plus A square. Okay, fine. So can we write this as A square minus B square plus C square minus 2BC? Like this? Now this is fine. Can we write like this? Guys, tell me.
Yes, sir.
And if you look carefully, this is A square minus B plus C whole square. And if you further rewrite, this is A plus B plus C, which is like A plus B into A minus B, which is A minus B plus C upon 2BC. Okay, long process. Okay. So far, so good. What we can do further? So I'm going to the next page and you just remember this answer. So 2 sine square A by 2 turns out to be A plus B plus C into A minus B plus C upon 2BC. Okay, well, fine. A plus B plus C we can add as 2S, if you remember. Okay.
Yes, sir.
And this we can write as, this is interesting. B plus C, I will add A here. And because I'm adding A, minus A is there. So I will also. So we can write like this, that's okay. Both are same thing, isn't it?
Yes, sir.
So this turns out to be 2S into 2A minus 2S. 2BC. Okay, so we got the answer. And it is really interesting. So why it is interesting? Because 2 sine square A by 2 is actually 2. What is that? A square minus. My bad. It is B minus C whole square. I made a mistake. You should have been careful here. That's why I'm getting something weird answer. It is A square minus B minus C whole square, right? Now this is fine. It is A plus B minus C into A minus B plus C. Now this is correct. Now I can go to here. I will remove this part. Okay. So 2 sine square A by 2 turns out to be how much? A plus B minus C into A minus B plus C by 2BC. Now this is fair enough. Okay. And we can write as A plus B plus C minus 2C. This you can write as A plus B plus C minus 2B to get the same answer as we had before. And now you can see this is 2S minus 2C. And this is 2S minus 2B upon 2BC, which becomes S minus A into S minus B. 2 to the 4. So this is 2, eventually 2 will left. and 2 sine square a by 2. This 2 will also cancel out. So we got sine a by 2 equals to how much? Under root of s minus a, s minus b by this. So you can get the sine a by 2 value in terms of s. This is how we get. Okay. If you want, you can get the cos a by 2 also. So similarly, how to get the cos a by 2? So we have the formula cos a equals to b square c square minus a square by 2bc. But to get cos a by 2, what I can do is I can add this as 2 cos square a by 2 minus 1. Okay, what I'm doing is I'm using the double angle formula. So I can add a as 2 into a by 2. And then you can do the same method. 2 cos square a by 2 equals to 1 plus b square plus c square minus a square by 2bc, which is like 2bc plus b square c square minus a square upon 2bc, and this is b plus c whole square minus a square by 2bc, which is b plus c plus a into b plus c minus a by 2bc. I hope you are not getting it. And if you're getting this bonus, so cos square a by 2 cos square by 2 is b plus c plus a is s 2s, and b plus c minus a we can attach 2s minus 2a, 2s minus 2a upon 2bc, which is like s 2s into s minus a upon only bc. Cancels out. We have 2 cos square a by 2. So basically cos a by 2 turns out to be under root of s into s minus a by bc. Fair enough? Okay, but what we're looking for is sine a. But no problem, we can add sine as 2 sine a by 2 into cos a by 2. And we know the answer for both. Sine a by 2, we got how much? Under root of s minus b into s minus c by bc. I think this is what we got. Yeah. S minus a minus s. This is s minus how much? S minus c. S minus c. C. So we are getting s minus b, s minus c by bc, and cos a by 2 we got under root of s minus a by bc. And if you look carefully, this is how much? The bc will come outside 2 by bc. And what we are left with? Oh my god. And now you know this left LHS. We can add as bc sine a by 2 is under root of and this we call the area of triangle. We know this answer, and because we have proved that this is equal to this, so now we know the formula for the Hieronymus formula, which is, so this is what you studied in class, I don't know which class, must have seen before. Now what I showed you is the derivation. This is how we can derive using trigonometry. Okay, so with this I'll end this trigo discussion, and we can go to something called algebra. So if you have any doubt in trigo, you can ask before I move further. No, these kind of manipulation will not come in one day. You have to keep on doing it to feel it. It never comes in one day. You have to do a lot of questions. Maybe you will end up solving 300 to 400 questions. After that, you will get the same fluency as you will see here. Okay, so anyone any doubt in this? The entire derivation or derivation different in this? One more thing. Okay. Just like the double angle formula, we also have the half angle formula. I should have done this explicitly. So sine A, if I want to write as a product of two terms, so I can write as sine twice of A by 2, which is like sine 2A formula, which you can write as 2 sine A cos. Like this. You can keep on dividing like this. And you can keep on writing like this. Cos A by 2 is 2 sine A by 4 cos A by 4 and so on. You can also keep on dividing into half and half. And similarly, if you know the cos 2A formula is 1 plus cos A, or whatever, cos square. Or you can write cos 2A, we wrote as cos square A minus sine square A. So you can also write cos A as cos square A by 2 minus sine square A by 2. So 2A becomes A. So A becomes A by 2. And similarly, A by 2 becomes A by 4. And you can keep on doing something like this as and when required, and so on and so on. There is one particular formula which is very, very interesting to us. What is the value of 1 plus sine 2? Like, can we take it out of the bracket, square root? Manipulation to get rid of square root. I want to get rid of square root. Do we have some trick?
One can be written as sine square plus cos square.
Yeah. So this is basically sine square A plus cos square A. And sine 2 we can write as 2 sine into cos A. And this is A plus B whole square, right? So this is interesting that this root we can always get rid of. Very good. Simple manipulation. Sometimes it doesn't look like that. We can play with 1 also. In Trigo, we can play with 1 a lot, and we can convert 1 into desirable formula. One more thing I would like to just express. Whether it is sine, cos, or tan, every trigonometric ratio can be expressed in terms of tan. That's very famous. And again, that is required for the integration manipulation. So, how to write sine 2A in terms of tan? Okay. How to write? So you can write as 2 sine cos A. To bring a tan here, I can divide by cos A. So this is manipulation. I know this answer. So what is the next step? I will do the manipulation. So to get the tan A into picture, I will divide by cos A. But because I have divided the cos A, I will square it. Now this becomes tan, right? So 2 tan. But I don't want anything else other than tan. So cos square I can write in denominator as sec square. And we know the sec and tan relation. 1 plus tan square. See, you can convert the sine into complete tan relation. And this relation is again very much useful in integration chapter. Can you guys try to convert cos into tan relation by doing some manipulation? Try for a while, then I will. Okay. Please, everyone. Try to convert the sine 2A, cos 2A into purely tan relation.
So is it 1 minus tan square A upon 1 plus tan square A?
Excellent. That's correct. Tell me, you derived?
Yes, sir.
Very good. Can you explain the process, like how you thought and reached the answer? Because that process will help everyone else to understand. So just a moment, just a moment. So okay, you have cos 2a, and then what you did next?
So we write it as cos square A minus sin square A.
Very good.
And then divide the entire equation by cos square A.
Oh, cool. And then you also multiplied.
By cos square A. Yeah.
So now this is something you did, and then you what you did next?
Then I got cos square A minus tan square A. And
Yeah.
cos square A, we can write it as 1. And the denominator, we can write it as 1 plus tan square A.
Yeah. So this term, if you break, you will get 1 minus tan square A, right?
Yeah.
And this cos square A, you can bring in the denominator as sec
1.
square, right?
Yeah.
And then this is 1 minus tan square A. This is 1 plus tan square A. Very good. Excellent. Huh? See, am I doing something extraordinary? No. What I'm trying to do is manipulation. And what I'm trying to teach is same manipulation. So Trigo is all about manipulation. What you want to get, what you have, and how to reach from there to there. So I hope you can also derive for tan 2a in terms of tan. I think this is going to be anyway easy, right? This is direct formula. So what is the
2
tan
tan
formula?
A by 1 minus
Yeah.
tan square A.
Correct. So that's the direct formula. 2 tan A. So let's say while solving some physics question, you get stuck with the equation like sine 2a plus cos 2a plus 2. Some you got some maybe 1, and you're trying to solve this. Now, technically, you can solve by various methods. So this you can write as 1 minus cos 2a, and this will become 2 sine a into cos a, and this becomes 2 sine square a by. I mean a. Because it's, okay, and then 2 cancels out, sine cancels out, and this becomes tan a equals to 1, which means a is 45. But of course, this is easy one. We got the answer. But what if this is not 1? If it is 2 or 3, I mean, of course, it cannot be 2. It is some fraction, let's say 1 by 2. So this was the easy question. But if I have sine 2a plus cos 2a, turns out to be, let's say, 1 by 2. Then how to solve this question? And it turns out to be that this is pretty easy if you convert into a single uniform formula. So we know the relation, we can write as 2 tan a 1 plus tan square. Now that's very subtle difference. In the sine and tan, the sign is here different. In sine 2a, we have 1 plus tan square. In the tan 2a, we have 1 minus tan square. So you have to be very careful. And this is something simple. And we can play with this idea. If I take tan a as x, now this becomes a simple quadratic formula. 2x upon 1 plus x square. 1 minus x square is 1 by 2, and then I can manipulate. So 4x plus 2 minus 2x square is 1 plus x square. So what I get is 3x square minus 4x minus 1 equals to 0. And now this is a simple quadratic to solve, which we are expert. So x is how much? Minus b. B square, 16 and 12. How much? There it is. 16, 12, 28 by 6. So I get 4 plus minus 2 root 7 by 6, which is 2 plus minus root 6 by 3. And then because x is tan, so I can take a positive value, let's say 2 plus root 6 by 3. Yeah, then I'll get a equals to tan inverse of this weird answer. Okay, it's really bad. But anyway, the purpose of all these manipulations is to solve something which is called trigonometric equation. So when we have equation in terms of trigonometric ratios, then we need to know how to convert into one form or the other form, which can be really powerful to solve. With experience, it will come, but of course, the experience will come with practice. If you start today, maybe after 3-4 months, you will be really good at it. Okay. Okay, one more thing that is very, very important in physics is called the concept of maxima or the minima, something like this. So I mean, I'm not finding any suitable heading for this. Okay. So sine and cosine are similar function. The only difference is they differ by the angle. So sine is the complementary of cos is the complementary of sine. So they are only complementary. So sine 90 minus theta is cos theta or cos. So these two are not entirely different. This is just way to represent. So sine represents the complementary of the given angle. Yes or no? Hello, hello, hello.
Yes, sir.
Yes, sir.
So sine and cosine are not different. It's just a way of writing. And therefore, there is always a relationship between these two. So when we have a term like this, A sine theta plus B cos theta. So this entire term we can convert into a single sine formula or single cosine formula. So although it looks different, but it is a single term which we can convert. So what are the rules to convert? Okay. So first of all, check the coefficient A, B. Step 1. Square and add the coefficient. So let's say we have a C which is equals to under root of A square plus B square. Now how to represent this relation in triangle form? Can we write like this? A, B. So this is like a Pythagoras in which I call this as A, this is B, this is C, and this is alpha. All right. So what I will do next is we multiply and divide by C. So C into A by C sine theta plus B by C cos theta. This is the method of doing it. And C we can write as under root of A square plus. What is A by C? Can you tell me what is A by C? What is cos alpha?
A by C.
And what is sin alpha?
B by C.
So can we write this as A by C was cos alpha? So can we write as cos alpha sin theta plus sin alpha cos theta. To make it better in terms of looking, sin theta cos alpha plus cos theta. And do you guys remember what is this?
Sin A plus B.
Very good. So what you learn from all this manipulation? We learned that A sin theta plus B cos theta. Then always we written as A square B square sin theta plus alpha, where alpha is, oh, what is tan alpha? B by alpha is basically tan inverse B by. Okay. Okay, what is the maximum value of sin theta?
1.
So what is the maximum possible value of this value? So we can add this as this, and the maximum of this will be when this is 1. Because sine of any angle cannot exceed 1, isn't it? Sine of any whatever angle it is. Can we have more than one answer? No. So what is the maximum value of this entire term? 10. Hello.
A square plus B square.
Under root. Yes.
Yes.
So this is what you have to always remember, that A sin theta plus B cos theta, the maximum possible value is, and for some angle it will be maximum. And when this is going to be maximum, when sin theta plus alpha is 1, which means theta plus alpha is 90 degree, when alpha is 90 minus theta. So when tan alpha is tan 90 minus theta, which is cot theta, and tan alpha we got is B by A. Okay. So tan theta is basically A by B. And theta is tan inverse A by B. So at this particular angle, the function will attain the maximum, and the maximum value will be equal to A square plus B square under root. That is what you have to remember without worrying much. So you will get to see the application very soon in chapter of Newton's laws of motion. So if I ask you, what is the maximum value of where mu is some constant, what is the maximum value of this? Come on, guys.
Root of 1 plus mu square.
Very good. What is the maximum value of this?
5.
Excellent. Now, don't worry if it is a if the sign is negative. So if I ask you what is the A sin theta minus B cos theta, if I ask you the maximum value, it will be same. It will be same. So what you can add here?
Root of A square plus B square.
Very good. So if you remember, if you can remember, it's really good. If you don't remember, don't worry. So let's say in a chapter you will come across, let's say if a force is something, and if we write as mu mg upon sine theta plus mu cos theta, where theta is variable, where theta is variable, and because theta is variable, so we can say the denominator will be a variable term. So I want to know the minimum value of f. Find f minimum. So f will be only minimum when the denominator becomes maximum, correct? There is no way out. How to minimize this term? By maximizing the denominator, because the only denominator is variable, everything is constant.
Yes, sir.
I cannot alter this value for sure. So the question is, what is the minimum value of this? So this we can write as mu mg upon this something maximum. That's all we can find. And what is the maximum of the denominator?
Root
Root
of
of
1
1
plus
plus
mu
mu
square.
square.
And this is the toughest question of IE in chapter of friction, which we'll learn later on. There is an application, that's why I'm teaching it. And the problem is, in physics, I need entire maths at once, which is not possible to learn or to be taught by any means. So don't worry if you don't get everything. I mean, don't take it on your heart. Okay, I'm not able to get entire maths, rest of everything. It goes this way only. I mean, even as a student, we don't get everything at once. So you will get something, will not get something, but just keep your patience. As the chapter will course will progress in maths and physics, these all terms are going to be repeated. Now it doesn't mean that you will not, give focus on what is being taught now, just because it's going to happen again. Don't keep that mindset. Okay? You'll try to learn as much as you could. The rest, time will teach. Okay. So no need to worry. I mean, many students think that, okay, I'm not able to get what is being taught. So many formulas are wrote at once. It is not possible to digest everything. That's totally natural and okay. No need to worry. With time only we digest. Okay, so for me it may be easy, I know, because I have been doing for a long time. For a student it is not easy, which again I know. So as a student, the struggle is there. Then can I keep on teaching Trigo for 1 year? The answer is no, I cannot teach. Is it my syllabus to teach? The answer is again no. I'm not going to teach. I'm just giving you the glimpse of maths, so that when I'm teaching physics and if I need somewhere, you should not be disturbed at that moment. So that is the whole idea of teaching mathematics as a basic tool to learn physics. And maybe by doing so, you get some insight into the world of mathematics that may help you in learning maths also. Okay, so my goal is not to teach you maths, because that's a huge, humongous topic, and I will leave that to the maths teacher. So that's their job of doing it. Okay, so now we are good to go with a new branch of maths. Enough of trigo. And guys, please, if you have bought SL only, start solving from first chapter. You will enjoy it a lot. So can we start the next topic?
Yes, sir.
The next topic name is algebra, as we call it. So this was developed by an Egyptian mathematician. So you can say developed by an Egyptian mathematician. His name was Al-Zawahiri, and he called this as Al-Zabar. So you know Al-Qaeda, okay? That's very famous bad name. The Al word is a very it's a very respected word in Arabic. It's not Urdu, it's Arabic actually. So you know algorithm. Again, it was developed by some Persian guy. This is he was Persian actually. Persian mathematician. So we have algorithm. Algebra, Al-Qaeda, Al-Kemi, very famous. And there are many Al. So Al is like the Shri in what we use in Hinduism. So Sri Sri Ravi Shankar. You give respect to the name. You add before some respectable name. In Asian language, if you go to China, the Mandarin will use the word Khai, which is similar to the word Al, to the word Shu in other language. So the Khai, this is called Khai. Khai, which means energy. So the Chi, you can say Chi or the Khai. This means energy. So Chinese is energy for the food with a lot of energy. Okay, don't take it otherwise. Okay, these are like naming convention. In different culture, we use different. So the entire, you can say not entire, of course. I mean, it will have some contribution from other countries also. But majority of the algebra was developed by this person, mathematician, Al-Jawahiri. I think I remember the name. If I'm not correct, you can rectify next time. Okay, this is just a way of naming it. So just to be secular, I will remove all this. So that is how it developed. In algebra, what essentially we study? What we study? So essentially what we study in algebra, tell me guys, anyone? So we study about equations, right? And inequalities. So in algebra, we study about equation, inequalities.
So logarithms.
No, logarithm itself is a branch. It's a separate branch. You can say logarithm itself is the world of exponential function. I will teach you a bit of logarithm. If you're learning, are you learning in maths the logarithm?
Yes, sir. We are already done with it.
Okay, great. And equation?
So
Are
equation
done?
also done.
Very good. Quadratic is done.
No, sir, not quadratic.
Then which equation?
Like normal inequalities, linear equations, 17.
So we have equation, inequality, and identity. So we discussed identity in the last class that any expression which is true for all variables we call identity. Equation is true for some values. An equation is you equate to something and then try to find the variable which can match the something written on the right hand side. Okay, so these are the ideas in equation. In equation, we have something called degree, okay? And we call degree of polynomial. So, okay, I'll not go in detail of anything, but just to remember, equation deals with two things: variables and coefficients. So the purpose of equation is to deal with variable and coefficients, and we stick to the single variable function. So our syllabus is all about single variable if it is multiple variable function, there must be some way to convert into single variable. Again, that you will learn later on, that how to convert basically the multi-variable function into single variable by finding some relationship. So we have to deal with variable and coefficient. Variables are like something which can vary, which can change, and coefficients are some suitable multiplier to create the equation. So I was teaching one student a long time back. It's a story of 2006. How many years? Roughly 16 years, right? So I was teaching one guy from London. He was studying there. I think he was in class 6th. and some faculty was not there, so I just someone told me, okay, can you teach class 6? And yeah, I can teach class 6, it's not a big deal. So that guy came to me, very small kid, nice question. He was asking me something really powerful. So he asked me that, sir, why we introduce or why we use variable in algebra? It took me some time to answer his question. Now the same question I'm asking to you. A class 6 student is asking me why we use variable. What could be the possible answer?
So to represent the not like the values which are not known.
Correct. So the whole idea is math is a literature. A literature full of symbols. And the English literature or the language literature in languages are descriptive. So there you write everything, you write, let's say your age is this, my age is this. So you use English sentences to express the situation. The variables are like a way to reduce the writing effort, and then you just bring a notational value which represents someone. So you say, let your age is X, let my age is Y, the sum of age is this. So it's a language which you convert into a symbolic notation, and that is why math is mostly literature. And learning math is all about learning literature and how to deal with literature, how to express it in a way which is easy to the mind, okay, and also which is convenient to write. So okay, fine. So I explained that's the purpose of variable. Then the next question is why we introduce coefficients. So what is the purpose of coefficients? Tell me. What is the purpose of coefficients? Tell me quickly. So again, it's simple. Huh? The coefficients are like every polynomial term, like every variable. To relate with other variable, I need to multiply with some suitable number so that we can equate. So there are many ways to interpret, but for a beginner, you can say coefficients are those number which you multiply to get the exact relation. So by multiplying with coefficient, we try to obtain the exact relation. So you can think in a very different perspective. Let's say we talk about something called polynomial. Polynomial. So what is polynomial? Poly means many, and nomial means terms. So when you add multiple terms, what you get is called polynomial. And in high school, you have studied it. So the first thing is called zero order polynomial. Which is also called monomial. Monomial. But we, as a literature, we assume the part of polynomial, but it's a single term. Although poly means many, but again, mathematics, everything goes this way. So any number which you write, let's say you write 5, 10, nothing is written, we can add this as some variable power 0. So it is also written in terms of variable, but the power of variable is 0. You can think that way. So every constant is a monomial, a single term. And this is called zero order polynomial. When you use the variable to the power 0 itself. Okay. So what is the first order polynomial? What is the first order polynomial?
Degree 1.
Yeah, so the highest power should be power 1. And any number can come. You can put any number, let's say a. The other lower term may or may not be present, but that really doesn't matter. You cannot b x power 0. Now, if b is 0, you will have only one term. If b is non-zero, you will have two terms. So what we call this first order polynomial? The first order polynomial we call linear equation or linear expression. As of now, I can say linear expression because I am not equating to anything. So as of now, it's just expression. When I will equate to something, it will become equation. So linear expression. So in linear equation, what is the rule? The highest power should be 1. Okay. There are some other rules. The power cannot be negative. It must be positive power. The power cannot be fraction. So when we talk about polynomial, we cannot take fractional power. We cannot take power which is square root term or cube root terms, something like that. The power must be integer. And first order means the maximum power is possible is 1. You can keep on any lesser values. That's all. And then we call the first order polynomial as linear expression. So what is the next term? Obvious term. So the second order polynomial, what we call this? It's very famous. So for second order polynomial, this we call in maths quadratic expression. So this is called quadratic expression. And the rule is the highest power should be 2. You can multiply with any number. Except which number? I want this power to be part of my expression. So can I take a as 0? Hello, guys.
No, sir, you can't take it.
Cannot take a as 0 because I want the term of x square must be part of my system. So I can take any value of a except 0. I can take some coefficient into low power. I'm done. I cannot take negative power, so I will not go further. And this entire term we call second order polynomial if a is non-zero. Similarly, this entire term is called linear expression if a is non-zero. There is no condition on b. B may be 0, may not be 0. It really doesn't matter. Okay. Okay. Then you can add third order polynomial. Third order. So what is the meaning of third order polynomial? The highest power I want is 3. And therefore, whatever I multiply should be non-zero. You can multiply any number. I'm just writing a. And this is the third order polynomial if a is again not 0 because I want a to be non-zero, then only it is possible. Okay. Now see, if we have cube, then I need a, b, c, d. If it is quadratic, we choose a, b, c as coefficients. But if we keep on going like nth order polynomial, if it is nth order polynomial, which means I really need some better way of writing, but this way of writing is not good. If n is more than 26 alphabets, then we don't have even alphabet left. So the way of writing is we write some subscript notation. So we can write as a n x to the power n, something like this. You can add a n minus 1, n minus 1, and then if you go to the dot, then something like a2, then a1, then a0, something like this. And we were done. This is how we represent. You can also represent in the reverse order. You can say a0 plus a1x plus a2x square. And the last term will be an x power n. And here, what is the condition? If this is the nth order polynomial, if what is non-zero? So what should be non-zero, guys? Tell me. So when this will be called the nth order polynomial, if which term is non-zero? Come on, tell me.
Sir, an.
Very good. Because the highest power is x power n, and I want that to survive. So the coefficient of that term should be non-zero. This is called subscript notation. So when you go for the large number of terms, the ABCD is not a nice way of writing. So we write the subscript notation because that will help you in writing any number of terms, even in that terms exceed 26. You can write. Okay. And if you look carefully, if you look at this term carefully, this is nothing but the dot product of two vectors. The first vector is a naught. I cannot go beyond 3 term. So if I take up to 3 term, I can add a naught I cap plus a1 j cap plus a2 k cap. And if I say the q vector equals to 1 I cap plus x j cap plus x square k cap, what is p dot q? You can see I with I, a naught, j with j, a1x, k with k. So up to quadratic, I can write as a dot product. Beyond quadratic, we write as a matrix or matrices, I mean, product of matrices. So that's very difficult for you as of now. It is written like this: a1, a2, dot, dot, n, and then we multiply with matrices like this, which is 1x, x square, and dot, 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 x. Okay, so in chapter of matrices, you will come across all this. That every polynomial we can write as a product of coefficient and the variables. And you can treat every term as separate variable. So let's say x is a variable, x square is another variable, and so on. Something like this. Okay. Now we are particularly interested in something called binomial. So what is binomial? So bi means 2 and nominal means term. So we have 2 terms. So let's say we have 2 terms a and b. Okay. So we have 2 terms a and b. What is the a plus b power 0? How to write? We can write as 1 because anything power 0 is 1, right? What is a plus b power 1?
A plus B.
A plus b. What is a plus b power 2?
A square plus B square plus 2AB.
And what is a plus b power 3? What is a plus b power 4? What is a plus b power 5? What is a plus b power 6? So what do you think, that I must have mugged up all this formula? The answer is no. In fact, I only know this one. The rest I can derive only by writing. So have you seen the pattern? Anyone who has got the pattern? I was doing some trick actually.
Yes, sir. I think I got it.
Yeah, very good. So this is called Pascal Strangle. So remove A and B. If you remove A and B, you can see something really simple. It is 1, then 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 6, sorry, 5, 1, and so on. I don't have space, so I'm leaving it. The coefficients are forming a triangle that is called Pascal's triangle. And you have to just remember up to here. After this, you can derive, because 1 plus 1 is 2. Add these two values, it is 2, and then write 1 and 1. The corners will be 1 and 1. Then again write 1 plus 2 is 3. 3, then 1 and 1. Then 4, 6, 4, 5, 10, 10, 5, 1. And then you can further keep on doing the next and the next and the next. So that's very pretty simple. This is called Pascal's triangle. And when you put the more and more powers, the coefficients are really easy to write. And how we write the power? Do you see the pattern of power? I start with the highest power of A. I reduce the power of A and increase the power of B gradually till I get the highest power of B. Do you realize this?
Yes, sir.
See, I see. I start with power 5. I reduce the power of A by 1, so it's 4. But to balance the net power, the B is 1. See, the net is 5. Then 4 becomes 3, B 2, again 5. 2, 3, 5, 1, 4, 5, then 5. Then I stop. So it is like this. You reduce the power of A and you increase the power of B. So highest power to the lowest power. And B goes from lowest to highest. So this is how we write every term. And you can write any power. So you can write, okay, who will tell me the next term? A plus B power 7. That's pretty easy. Tell me, guys. By looking at the formula, you can tell. The first term is going to be simple. A power
8 raised
7.
to 7.
The next term will be, can you guess?
7.
A raised to 6.
Very
B
good.
raised to
Next term,
21. A
Very
raised
good.
to 5.
B
B
square.
square.
Because power, the sum of the power is always 7. The next term,
35.
35.
excellent.
A raised to power 4B.
And after 35, the next term is,
35.
and power is A power.
3B power 4.
Very good. The next term,
21.
excellent.
8 to the power 2, B to the power 5.
So A to power B power 5. Yeah. Then last, I think one more time. Yeah, the two more times. Next one.
20, sorry, 12.
No,
7.
it's a B actually.
Oh,
It's a 7. Yeah.
7.
A, B power 6. And the last is always B power 7. Okay. So, okay, you can write any power, no need to worry. It's called Pascal Strangle. It's a very famous triangle. You can search on Wikipedia to know more about history. And always have the curiosity to read about something, which I just share out of blue, read about something. Always search for the history of mathematics. It is very convenient to understand maths if you know the history or the reason behind why we define the way we define. The same is true with physics, but don't worry. For physics part, I am there. I am going to show you or tell you the entire history. The history is a way, I mean, for me, it is a convenient way to understand science. Why? It gives me perspective. It gives me the chronology of event. And when I know something chronologically, my brain is at ease to remember the event. So there is a natural flow of science or the progression in science. And through that natural progression, brain is at ease to remember the events. So that's why I suggest that, okay, always try to understand the science through some historical perspective. Have the curiosity to search for that. Some interesting mathematical tricks I'll just teach you. So what is A minus B? A minus B. That's simple. What is A square minus B square?
A plus B into A minus B.
I'll add A minus B into A plus B. I prefer this way for some reason. What is A cube minus B cube?
A minus B, A square plus AB plus B square.
It's the same thing. You increase the power. You start with the highest power. You keep on decreasing and increasing the other power, right? And this will go interesting this way. Can you guess the answer?
A cube
Mhm.
plus A square B plus AB square plus B cube.
Very good. Simple. A power 5 minus B power 5. Same. No need to worry. It's very, there is a pattern actually. A power
A raised to 4.
A to the power 4 plus A cube B plus A square B square plus AB cube plus B to the power 4.
Okay, so this way, A power n minus B power n, what you can write? So one term is fixed. A minus B, I'm going to get, yes or no? And then I'll get something really big. So A n minus 1 plus A n minus 2B, A n minus 3B square. And this is very difficult to write. So I'll go this. And eventually I'll get A square. The net power should be n minus 1. Okay, the net power is, so this will be B power n minus how much?
3.
And then last will be A B power n minus 2. And then B power n minus 1. Over. Now, what is the takeaway from this particular mathematical discussion? And the takeaway is A power n minus B power n is always divisible by A minus B. It is a perfect number, perfect integer. Because it is perfectly divisible, isn't it? Because it is something A minus B into number. So I can divide, isn't it? So this is a divisible theorem. Like this is called divisibility. Divisibility theorem. and it's again powerful. If someone is having interest in preparing for a regional maths Olympiad, so something like this will help. We call it a divisibility theorem. So anyone interested in the maths kind of Olympiad, and let me tell you the pros and cons. The maths Olympiad has nothing to do with the JEE. So the JEE syllabus and the math Olympiad syllabus is quite different. One talks about the application, and other talks about the theorems and various derivations from the scratch. The physics and chemistry Olympiad are actually JEE syllabus. So if you are preparing for the physics Olympiad, you automatically prepare for the JEE. But the same is not true for maths. If you have interest in mathematics, I'll suggest you what to do next. So you can connect with me. I'll tell you the sort of books you must buy at this stage to search through the world of mathematics. Most of the maths you have to study on your own because it's not part of JEE syllabus. Mostly it won't be taught in the classrooms. Anyway, so a power n minus b power n is always divisible by a minus b. That's the theorem. So if I ask you, let's say 10 power 243, oh my god, minus 3 power 243. If I divide by 4, what is the remainder? What is the remainder of this? Remainder. It is completely divisible, no? A power n minus b power n is divisible by a minus b, which is 4. Correct?
Yes, sir.
And because it is completely divisible, so are we going to get any remainder?
No.
No, so answer is 0. And if I ask you, find the remainder of 7 power 223 minus 3 power 2023 plus 1 divided by 4. What is the remainder?
0.
1.
Oh, yeah. 1.
This part is divisible, 1 is not. So 1 is actually remainder, which is less than 4, no? Isn't it?
Yes, sir.
But if I write 5, if I write 6 here, then what is the remainder?
2.
2. Very good. See the beauty of maths. Once you know one concept, these are challenging problems. How to divide? So you should know the theorem, divisibility theorem. That's it. Okay. So maths is really interesting. It's really powerful also. And how to deal with this? Okay. Something interesting here. I'll just put it across. What is a square? Oh, this is difficult. What is a cube plus b cube? And we all know the formula. Okay. Now, when it is plus between the power of a and b, it can only be expanded if it is odd power. So I can write it for the like this, and the answer will be a plus b into. And now we must be thinking how to expand this answer. Actually, we have only one formula, the minus 1. But for odd power, we can convert into minus, right? Then what this has. Why? Because minus 1 to the power odd is minus 1. Minus 1 power even 1. This is a simple theorem. And how to write odd numbers? Anyone? How to write odd numbers? Okay, how to write even number? 2 into any number is even, isn't it? Every even number we can write as 2 into n. Yes or no? 2, 4,
Yes, sir.
6. So how to write odd number?
2n plus 1.
Where 2n plus 1 or 2n minus 1? So if you add or subtract one from the odd, from the even, you get odd number. So if someone is writing you -1 to the power 2n plus 1, what's his answer?
-1.
Very good. You guys are genius. -1 to the power 4n.
1.
1.
Yeah, it's even number. So 2n, 4n is even of even. Okay, yes. Anyway. Okay, these are very simple things, but one should be aware of. Okay, so what I was saying is that the moment we have the odd power as a summation, we can convert into the difference. And when we can convert into difference, we know the formula for the difference of two terms, right? So the difference what? A minus B, A minus B into A power 4 minus B. This is how we start. Sorry. The first term is A power 4. Second term is what? A power 4 minus B. Third term is A cube minus B squared. Third, next term is what am I doing? So first term is A power 4. Next term will be A cube minus B. Third term is A square minus B whole square. Fourth term is A minus B whole cube. And the last term is minus B power 4. So if you look carefully, this turns out to be A plus B. A power 4 minus A cube B plus A square B square minus AB cube plus B power 4, which means every term with odd power of B will be negative, and every term with even power of B will be positive term. So this will become something like this. I cannot write a formula for this, not possible, because even power I cannot convert into minus, and so I cannot expand by the formula. So the plus is only possible with odd powers. So I can write A7 B7, and the first term will be this, and the start with 6. The next term is odd of B. So you can alternate the plus minus. That's very easy. First is plus, then minus, plus, minus, plus. You can just alternate. A power 5 without worrying much. Just alternate the sign. A cube, B cube, A square, B power 4, A B5. That's it. Oscillation. Every term will oscillate. It's like oscillation terms. Very interesting. Plus, minus, plus, minus, plus, minus. Okay. Is this clear, guys? Hello, hello, hello.
Yes, sir.
Okay. So when we have the addition, then the divisibility is only possible for A power n upon B power n is divisible only when n is odd. So for n is even, it is not divisible. Okay. So I hope this is okay. This is not very difficult. The last page left on this Zoom. So I would like to dedicate this for the quadratic part. So I hope you all know how to solve quadratic. So how we solve quadratic?
Sir, either by the formula method or the factorization.
Yeah, factorization. So we know that A must be non-zero. So I can take A comma. So we can only solve if the terms, see, x is available as x square, x is available as x also. So I do not want to multiple spread term because I want to solve for x. The only way is to factorize. So how to convert into perfect square? Any idea? In class 10th, you might have done this, converting into perfect square. In class 10th, how you derive the formula of quadratic? Did you mug up or did you derive? Tell me, honestly. Hello, hello, hello. No one derived?
No,
guys.
no,
Please
sir, in
share.
school
See,
we never
because
divided.
Sir, it
Derive.
was not in the portion.
oh my God, this is the classic answer.
Sir,
This is
COVID batch.
this is generally given by teachers.
कैंसिल हो गया था
Acha. Okay, really interesting. Anyway. Okay. So now see, this part is crucial part. We must understand. Therefore, I will derive it. It's not difficult. So derivation will have few certain steps. The first step of derivation is make the coefficient of x square the highest power 1. How to make the coefficient 1? By taking a comma. So you can see that is the first step. Okay. And because a is non-zero, so if the product of two number is 0, and if the first number is non-zero, then second number must be 0, yes or no? A into something is 0. A is non-zero. So something must be
Zero.
0. So this implies x square plus b by a into x plus c by a equals to 0. Can we write like this? Now the question is how to convert into perfect square. So we have a square and we have 2ab term, something like this. So we have a square. So how to make the term as 2ab, a square plus 2ab. So I want to convert this into 2a. So what we must start here, b. A square plus 2ab. What is b here? B by 2a, because eventually I cannot disturb the term. No? I have to just manipulate the term. So can we write bx by a as 2a b by 2a?
Yes, sir.
How many of you are getting this part? That this term we can manipulate as 2ab, but 2 is not there. So since I'm multiplying with 2, I must divide by 2 to make it as it is without affecting the actual term. Yes or no? Hello, 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 hello.
Yes, sir.
I think not everyone is getting it. Are you getting this conversion part? Bx by a can be written like this.
Yes, sir.
So we have a square, we have 2ab. What is missing here to make it perfect square? What
B
is
square.
missing? B square. What is b by the way here? What is
B by
b? Pardon? Yeah, tell me.
so C by A. So as in B square. No?
No. I'm asking what is the b if it is 2ab. This is 2, this is a, this is entire term is b, no?
Acha, B by 2A.
So what we must write here? B by 2a whole square.
Yes.
Because if I write something like this entire term become perfect square, yes or no? Tell me yes or no.
Yes, sir.
But the term which I wrote here, is it present actually? In
No,
the
sir.
actual expression, is it present? No. So if something is not present and if I have added here, I must subtract. Yes or no?
Yes.
Because this is actually not present in the actual term, right? And C by A is present, yes or no? C by is
Yes,
actually
sir.
there, no? And this equals to 0. So from going from here to here, we have done a lot of manipulation, but have we disturbed the entire term? No. Both terms are same, but there is a benefit. Now the term in the bracket is a perfect square. What we can write that term?
X plus b by 2a whole square.
Very good. And every term beyond this is constant term, right? There is no x here. Can I throw on the other side of equal? Yeah, we can throw on the other side of equal. So this will become b by 2a whole square minus c by a. Yes or no? Yes
sir.
or no? And you know how to take the LCM. This is 4a square minus c by a, and we can write LCM. So can we take LCM here? What is LCM? 4a square. So b square minus what we can write here? A 4a square. Come on, guys, tell me.
4ac.
4ac. Very good. Okay, so this is the entire number. No, this is just a number in some symbolic notation. Okay. And because this is a number in a notation, so what we can write? So a square of a number is this. So number may be. Okay, if x square is 2 or let's say 4, so x may be.
Plus
Plus
minus
minus 2.
So anything is possible. Similarly, if a square of this term is this number, so the number must be equal to either plus or minus of this entire term with under root.
Yes.
Yes or no? Can we write like this, guys? Tell me.
Yes, sir.
And this we can attach under root of e square minus 4ac, and 4a square we can attach 2a. Okay, so now this is either plus or minus. So what is the x value? Minus b by 2a plus or minus b square minus 4ac upon 2a, and because 2a is the same as a minus b plus minus under root of b square minus 4ac. And plus minus is saying there are two possible answers, one with plus, one with minus. So a quadratic expression equation will have maximum two possible solutions. So maximum, I'm saying maximum two. It could have no solution or two solutions or one solution. That maximum is two. So it can have 0, 1 or 2 possible answer in real number scale. So if we talk about the real answer, there is something called imaginary answer, which is also possible, which we'll study. Okay, so when it will have two possible answer, so again we have something called square root term. Oh, ding dong, the space is over. So okay, I will discuss a lot of properties of quadratic in the next lecture. What is your job till now? You will derive the quadratic the way I derive till you realize. Okay. So you will derive it first. Second is you will also start solving the trigonometry questions. Those who are willing to solve more will start with SL only, but those who are very much reluctant to start right now or will rather do it when the mass will happen, for them you simply solve NCERT. At least you need to have some practice, because I'm not giving you a separate sheet for this because books are there. You solve NCRT or SL only, and we can discuss in one lecture about the doubts. So you have 1 week, complete week I'm giving you. Keep on solving. Meanwhile, I'll come to calculus. So what I want is that in 1 week, you try to reach as close to the completion of these formula as possible, so that when I start calculus, you don't feel a burden of backlog of trigonometry. The quadratic is something, again, if you want, you can solve from any book. You can solve from JEE book also. That's not a big deal. I'll teach you good enough so that you can start solving a good level problem, much more than what you can call JEE-Mains level. For advanced level, you have to go much deeper into the world of quadratic, which is not very easy. I will teach a bit of it because I need, of course, quadratic in chapter, very coming chapter called kinematics. So in kinematics, you have to deal with a lot of quadratic, and therefore I'll show you the different perspective in which quadratic is used. And some other perspective I'll explain. So next lecture is going to be mostly quadratic. And once I'm about to touch the calculus, I'll start the parallelly kinematics. Okay. So right now, because I haven't touched the calculus part, it's very risky to start because we need to derive differentiation, integration, everything very in the very beginning of the chapter. So please, guys, start practicing trigo. Don't take it lightly. I know very few of you will focus what I'm saying. Many will ignore, and then in the last you will repent, as usually it happens. It's good to start now. If you have difficulty, you can ask in doubt class. I'll arrange for doubt class mostly next week by the time you have some practice. And if you do not decide to start with Loni, please start with NCRT textbook of maths. Okay, so that's the takeaway. Bye guys, take care. See you in the next lecture on Wednesday. Bye.
Bye, sir. Thank you, sir.
Bye. Good night, guys, everyone.
Thank you so much.